All right, today we're going to be doing lecture 21, which is combinations. Now, last time we learned about permutations, and we learned that a permutation is an arrangement of objects. It's going to be a special arrangement of objects where order actually does matter. Where order matters. So that's a permutation, and we learned about the permutation formula. It's going to be N permutation R. It's going to be equal to N factorial divided by N minus R factorial.
May I have your attention for this announcement? Teachers, please check your emails that were sent out yesterday regarding students that would be taking the business writing test. If you have any of those students, please send them to C209.
Okay, so that is the permutation formula. Your N is going to stand for your total number of objects. Your total number of objects. It's usually going to be the bigger number. And then R is going to be how many you're going to choose. So I like to call it the choosing number. And again, R is usually going to be less than N, but sometimes these two numbers can equal each other. Today, we're going to be learning about another type of arrangement called combinations. Combination. So a combination is going to be an arrangement of objects where order does not matter. It's going to be an arrangement of objects where order does not matter. So what this means is if you have a certain number of objects, you can rearrange those objects in a way so that the order doesn't matter. So for example, if I had the combination AB, that would be the exact same thing as BA. So notice that the order does not matter here. When you're doing the combination formula, it's going to be done a little bit differently from the permutation formula. It's going to be NCR. The C is going to stand for combination. And I can write this as a binomial coefficient where I have N at the top and I have R at the bottom. So the formula is going to be N factorial at the top, and then you're going to be dividing by R factorial times N minus R factorial. So the only difference between the permutation and the combination formulas is going to be this R factorial at the bottom. That is the only difference. So since you're going to be dividing by R factorial, usually there's going to be less combinations than you're going to have permutations. Because if I have a permutation, I can have AB and BA be separate objects. So in the case of a permutation, if I was to have AB, that would not be the same thing as BA, because the order actually matters when you do permutations. So those are combinations. And what I wanted to do was go over some of the classwork problems that we're going to be doing this week on the combinations classwork. So let's take a look at that. Okay, so we're going to be doing the combinations classwork, and I'm going to be doing all the even ones with you. Okay, so number 2 says we're given 4 different objects. And we want to list all the combinations of those 4 objects, taking them 2 at a time. So those 4 objects are actually going to be 4 whole numbers, 4, 5, 6, and 7. And what I want to do is I want to take them 2 at a time. 2 at a time. So what are my combinations going to be? Well, I could put 4 with 5. I could put 4 with 6. And I can put 4 with 7. So there's 3 combinations already. Now let's move to the combinations where the 5 comes first. We could have 5, 6. We could have 5, 7. Those are the 2 combinations where 5 comes first. And then there's only one combination where the 6 is actually going to come first. And that's going to be 6 and 7. So how many combinations do I have in total? I have 1, 2, 3, 4, 5, 6. So there are 6 different combinations that you can make. Notice that I'm not changing the order, right? What that means is 4, 5 is the exact same thing as 5, 4. So I don't need to list 5, 4. I already have it as 4, 5. So those are the 6 different combinations. Now let's use the combination formula to see if this is all that I need. I'm going to use NCR. N is going to be my total number of objects. That's going to be 4 objects. And how many am I choosing at a time? That's going to be 2. So my R value is going to be 2, while my N value is going to be 4. So now putting this in the combination formula, I know I need to put N factorial at the top, R factorial at the bottom, and N minus R factorial also goes at the bottom. So at the top, I'm going to have 4 factorial, and I'm going to have 2 factorial and 4 minus 2 factorial. Now I can simplify this a little bit because I know that 4 minus 2 is going to give me 2. So at the bottom, I'm going to have 2 factorial and then another 2 factorial. So the 4 factorial, I know that that's going to be 24. And since 2 factorial is just 2, I'm going to have 2 times 2 at the bottom. That's going to give me 4. So I'll put the 4 at the bottom. So then 24 divided by 4 is going to give me 6. So in total, I should have 6 different combinations. So that's a good way to check to see if you have all the combinations that you should have. Let's look at number 4. Number 4 says evaluate the following expression, 20 C 18. Now sometimes when I'm just saying this out loud, I'll say 20 choose 18. So sometimes the C is going to stand for combination, but I just say the word choose. So out of 20 objects, I have to choose 18 of them. How many combinations can I make like that? Well, the combination formula is going to be N factorial at the top divided by R factorial times N minus R factorial. So what I'm going to do is I'm going to let my N value be 20 and my R value be 18. So at the top of the fraction, I'm going to have 20 factorial. That's going to be a really big number. At the bottom, I'm going to have 18 factorial and 20 minus 18. So I have to subtract them as well. So what's going to happen there? Well, I can simplify 20 minus 18. That's going to give me 2 factorial. So in the denominator, I'm not just going to have 18 factorial, I'm also going to have 2 factorial with it, which of course is just going to be 2. So what I can do now is I can expand the top out as much as I need to. 20 factorial is going to be equal to 20 times 19 times 18, and I'm going to stop it right there and put the factorial symbol, because this 18 factorial at the top is actually going to cancel out with the 18 factorial in the denominator. So this 18 and this 18 are going to cancel each other out. I'm going to have 20 times 19 on top, whatever that number is. And 2 factorial is 2 times 1, which is just going to be 2. So now I can simplify the top a little bit and the bottom. If I divide by 2 at the top, I'm going to get 10. If I divide by 2 at the bottom, that 2 is going to be replaced by a 1. So now I'm dividing by 1. That's not going to change anything. So I'm just going to have 10 times 19 at the top. And that's going to give me 190. That's the number of combinations that I can create if I have 20 objects and I need to choose 18 of them. Okay, so that is just an example of using the combination formula to solve a question. And now what I want to do is I want to look at the word problems that are at the bottom of the page. So let's look at number 6. Number 6 says, a team of 14 softball players. A team of 14 softball players need to choose 3. Need to choose 3 players to refill the water cooler, but I'm just going to leave it as this. So what's my total number of objects going to be for this? It's going to be 14. What's my choosing number going to be? That's going to be 3. So now I've got 14, choose 3. Okay, so now I'm going to plug both of those numbers into the combination formula. I'm going to get 14 factorial at the top and 3 factorial at the bottom, and then 14 minus 3 factorial. So the first thing that I'm going to do is I'm going to subtract inside the parentheses. 14 minus 3 is 11. So what I want to do is I want to expand the top out as much as I can so that I can include the 11 factorial. So what is 14 factorial? That's going to be 14 times 13 times 12 times 11, and I'm going to stop at 11. So put down the factorial symbol. And in the denominator, I'm going to have 3 factorial times 11 factorial. So now do you see why I stopped at 11? It's because I have 11s on the top and bottom that I can cancel out. So when I do that, these are going to cancel out. I know that 3 factorial is going to be 3 times 2 times 1. That's going to give me 6. So I'm just going to have 14 times 13 times 12, all divided by 6. So now I can simplify a little bit. If I divide by 6 at the bottom, I need to divide by 6 at the top. So this 12 is going to change into a 2. So now I have 3 numbers that I need to multiply at the top. I can put the 2 with the 13 to get 26. So this is really going to be 14 times 26. So I'm just going to do the multiplication really quickly. 26 times 14. 6 times 4 is 24. Carry the 2. 4 times 2 is 8. Plus 2 is 10. Put down my placeholder 0. And now I need to multiply 26 by 1 to get 26. So now if I add the digits, I'm going to get 3, 6, 4. That's my answer. All right, let's look at 8. Eight says the student body of 280 students wants to elect 2 representatives. So this time, my total number of objects is going to be 280. And then how many am I choosing from that 280? It's going to be 2. So I'm going to have 280 factorial at the top, 2 factorial at the bottom, and 280 minus 2 factorial. So at the bottom, I can subtract 280 minus 2, that's 278. So now expanding the top out a little bit, I can do 280 times 279 times 278. And I'm going to stop right there. When you stop, make sure you put your factorial symbol down. So now the 278 factorial is going to cancel out on the top and the bottom. I've got 2 factorial, which is 2 times 1. That's going to give me 2. So I'm going to cross this out and replace it with a 2. And now what I want to do is I want to sort of reduce this fraction a little bit. If I divide by 2 at the bottom, I'm going to have a 1. If I divide 280 by 2, I'm going to get 140. So now I've got 279 times 140. So doing this really quickly, I'm going to multiply these 2 numbers together. And then 1 times 279 is just going to be 279. So now adding up all the digits, I get 39,060. That's going to be my answer. All right, number 10 says a team of 9 basketball players needs to choose 2 So this time my total number of objects is going to be 9, and I'm choosing 2 from those. So I'm going to have 9 factorial at the top, 2 factorial at the bottom, and then 9 minus 2, which is going to give me 7. So what I'm going to do is I'm going to expand the top out until I get to 7. Then I stop because I have a 7 factorial in the denominator. So those 7 factorials are going to cancel out. 2 factorial is just going to give me 2. 8 divided by 2 is 4. Put the 1 at the bottom. So now dividing by 1 doesn't change anything, but 9 times 4 is going to give me 36. And that's my answer. Okay, so that's the combinations classwork. So what assignments are going to be due on Sunday? You're going to have your permutations classwork. You're going to have your combinations classwork, where we just went over the even ones. And then you've got your permutations and combinations quiz. Okay, so that's all I need to talk about today. I hope you have a great day. Class dismissed. If you have any questions, go ahead and put them down in the chat box, and I will get to you very soon.